So we'll discuss two topics today. One is the sulfur, another one is carbonates. So existence of the sulfur, how it exists. Sulfur, as you can see, the symbol is S. Atomic number is 16 and atomic mass is 32. So when we write the electronic structure or electronic configuration of this sulfur, the first shell it will have 2 electrons because there are 6. The second shell it will have 8 electrons and the third shell it will have 6. Because there are 6 electrons in the outermost shell, that's why it belongs to group 6. And it belongs to group 6. It is a non-metal. Existence of the sulfur, how it exists? It exists as a yellow solid. At room temperature, sulfur is solid. So it is mined from a solid underground deposit of the elemental sulfur, like element sulfur is there, or extracted from the fossil fuel, received from metal sulfide ores when metal is extracted, and it is used in manufacture of sulfuric acid. That's a use of sulfur. Is it clear, the first part? The use of the existence of the sulfur and the use of the sulfur. It is used for manufacture of sulfuric acid, and from where we can extract, it can be mined underground deposit of the elemental sulfur, or we can extract from the fossil fuel. We can also receive from metal sulfide in extraction of the metal. So I want you to copy this part first. Then oxides of sulfur, there are 2 oxides of the sulfur. When sulfur react with oxygen, it has 2 possibilities to form oxides. Number 1, it can form sulfur dioxide, or it can form sulfur trioxide. Sulfur dioxide, manufacture of sulfur dioxide, how it is formed? When sulfur reacted with oxygen, the element sulfur burned in the presence of oxygen or burned in air, it produced sulfur dioxide. But sulfur trioxide is not a stable compound. How it is formed? When sulfur dioxide, which is already formed, further reacted with oxygen, this will result in a formation of sulfur trioxide. But this reaction is a reversible reaction. What does it mean? That the sulfur dioxide can react with oxygen and form sulfur trioxide, and sulfur trioxide can decompose and form back the sulfur dioxide. The equation must be balanced, so that's why I put 2. So equation is balanced. Sulfur dioxide is a gas. Oxygen is also a gas, and sulfur trioxide is a gas. I want higher amount or greater proportion or greater yield of sulfur trioxide. What pressure I should use, high pressure or low pressure, for this reaction to occur? Because when a reversible reaction is there, if we increase the pressure, the balance shifted towards side where less particles are present. So you can see there are 3 particles in the reactant side and only 2 particles in the product side. So this prefer high pressure. And this reaction is exothermic. When we say this reaction is exothermic, it means it releases energy. So exothermic reactions, when we make an energy profile diagram, so reactants having high energy where the product is having low energy. So sulfur dioxide is reacting with oxygen, forming sulfur trioxide. I want greater amount of sulfur trioxide. So the reaction is exothermic, shows reactant have high energy, product is having low energy. So what temperature we prefer to get a higher amount of sulfur trioxide? Pressure should be high. What about temperature? We should increase the temperature or decrease the temperature. So because the reaction is exothermic, so we should decrease the temperature or we should lower the temperature. Why decreasing a temperature? Because you have both reactant and product. So if I remove the energy, I decrease the temperature. So what I will get more? I will get more sulfur trioxide. So this reaction, to get a higher yield, to get a higher amount or percentage of product, we should have high pressure and we should decrease the temperature to get more sulfur trioxide. But when we decrease the temperature, the reaction is slow. So to balance this, to increase the speed of the reaction, we use a catalyst which is called vanadium pentoxide. V2O5 is a catalyst. What is the purpose of the catalyst? Because as you decrease the temperature, the rate of the reaction decreases. To increase up the rate or the speed, you use a catalyst which is vanadium pentoxide or V2O5. Is it clear? The oxides of the sulfur, two oxides, sulfur dioxide and sulfur trioxide. Any doubt in this part? Any doubt in this part? The two oxides of a sulfur, sulfur dioxide and trioxide. Sulfur dioxide reacted with more oxygen gives sulfur trioxide. The name of the catalyst is vanadium pentoxide. Vanadium pentoxide. Copy this part. Look how the pressure affects this position of the equilibrium. As you can see, if we have a container, we have two molecules of sulfur dioxide. We have one molecule of oxygen, and this will result in a formation of three molecules of sulfur trioxide. Now, when we increase the pressure, means we reduce the volume. So as we reduce the volume, so small space is available for the particles. So they have more collision more effectively because the proportion of the reactant particle is more. So there are collision between even reactant and product particles, between the reactant particle and between the product particles as well. But the reactant particles, as their proportion is more, so if we reduce the volume or increase the pressure, the particles come closer to each other, collide more often, and this will result in a formation of greater product. But what will happen if we reduce the pressure or increase the volume? So if we reduce the pressure or increase the volume, means more space available. So if more space available, you have like same sulfur dioxide molecules, two sulfur dioxide molecules, oxygen molecules, sulfur trioxide molecules. But as you can see, as a large space is available, the pressure is low. So the reactant particle, they are in a greater proportion, but they will not collide often. As they don't collide with each other easily, they will not form a product. So what happened? The products start to decompose at a faster rate as compared to formation of a product. So reducing a pressure will shift the equilibrium towards left hand side. So increasing the pressure shift towards right hand side, we're reducing a pressure shift towards left hand side in this example. Is it clear now? Then you have to learn the uses. Finish writing this part. The two oxides of a sulfur, sulfur dioxide and sulfur trioxide. Then you have to learn the uses of sulfur dioxide. It is used in manufacture of sulphuric acid. It is used to bleach the wool or wooden pulp, silk or wooden pulp. It is used as a sterilizing agent in making a soft drink. Sterilizing agent means it does not allow the bacteria to grow. That's why used as a sterilizing agent. And it's also used in drying fruit, stop growth of a bacteria and molds. So these are the uses you have to learn. You have finished writing this one? The uses of sulfur dioxide. Then the important part of this chapter is the manufacture of sulfuric acid by a contact process. So these are some uses of sulfuric acid. Sulfuric acids are used in fertilizers, for making paints, pigments, dye stuff, chemical manufacture, soap, detergent, fibers. All these stuff are made up of or consist of sulfuric acid. How we can, so it's a very important chemical because of its many uses. How we manufacture sulfuric acid in the industrial method, that's called a contact process. So what is the contact process? How we manufacture? So first what we do, we burn the sulfur in air. So sulfur react with oxygen. This will result in a formation of sulfur dioxide. Then the sulfur dioxide reacted with more oxygen in the presence of a catalyst, vanadium pentoxide, to give sulfur trioxide. This we already discussed, that we use a high pressure and we use low temperature. But you can see here that even I'm saying a low temperature, but what is the temperature written here? Temperature is written about 400 or 450 degrees centigrade. What's the reason for that? Because below this temperature, around this temperature, the reaction yield is optimum. Otherwise, if it is too low temperature, then the reaction will be very slow and it will take more time to get the desired yield. So sulfur reacted with oxygen gives sulfur dioxide. Sulfur dioxide reacted with more oxygen forms sulfur trioxide. Now, as you can see, so we have sulfur trioxide. If we have sulfur trioxide, what we can do, we can simply pass this sulfur trioxide gas, which is SO3, through water, which is H2O. So if we pass this sulfur trioxide through water, what this result? This will result in a formation of H2SO4, sulfuric acid. But the problem with this sulfuric acid, sulfur trioxide is a gas, water is a liquid at room temperature. But when this will produce sulfuric acid, this will produce vapors of sulfuric acid. So these vapor, like example, in a chamber, if you are preparing a sulfuric acid, so this reaction is a violent reaction which result in a formation of vapors of sulfuric acid, which is difficult to extract from the chamber. So that's why, for the safety reasons, we don't follow this procedure. What we will do to prepare this sulfuric acid, we don't use this technique. Which technique we use? So the sulfur trioxide, which is formed in the second reaction, reacted with sulfuric acid, H2SO4. So you are preparing sulfuric acid and you added small, but what happened? We add a small quantity of sulfuric acid. So sulfur trioxide plus sulfuric acid will give H2S2O7, which is known as oleum. And oleum is diluted with water to get sulfuric acid. So this sulfuric acid will be aqueous or liquid state. But when sulfur trioxide, if directly mixed with water, H2O, it will form sulfuric acid, but it will result in a formation of vapors of sulfuric acid, which is difficult to extract. That's why we don't follow this process. We carry out an indirect method, that sulfur trioxide mixed with sulfuric acid will give oleum. A small amount, this is a small amount of sulfuric acid. And You can see when we are adding one molecule of sulfuric acid, but when a product is formed, we are getting two molecules of sulfuric acid. So what it shows we are getting the one which we add and we are getting the one which is formed. It is difficult thing to condense the vapors of acid, because acid vapors are, if they are released to the atmosphere, they are harmful, can cause acid rain. That's why it is not done in this method. Is it clear? The manufacture of sulfuric acid by a contact process. So this is a very important topic. Copy this part as well. Sulfuric acid uses as well as how we manufacture by a contact process. So if we have aqueous copper sulfate, you can see it contains copper ion, sulfate ion, hydrogen ion, and hydroxide ion. So when we do electrolysis of this, copper ion is less reactive, move towards cathode. Hydroxide, because sulfate, nitrate, and carbonate does not move, so hydroxide will move. So what we are left with? We are left with solution of H2SO4 sulfuric acid. So a small quantity of sulfuric acid is mixed with sulfur trioxide, form oleum, and oleum is mixed with water to form sulfuric acid. So we get the one which we added and we get the one which is formed. Why we don't use this electrolysis to manufacture all the sulfuric acid which we need? Actually, we check whenever industrial methods are used, they always check the cost. That's an important thing. Availability of the raw material and the cost. Because when you're passing a current through an electrolyte to produce a large quantity or amount of sulfuric acid, you need a greater amount of copper sulfate, and then you have to pass through too much current, and then sulfuric acid is formed. So if you are doing electrolysis and manufacturing sulfuric acid, the cost is much higher. So industrial process in always check the cost and availability of the raw material. So sulfuric acid can be used as a drying agent or a dehydrating agent. So what's the meaning sulfuric acid as a drying agent or sulfuric acid as a dehydrating agent? In both cases, it is removing the water. The term drying agent or dehydrating agent what is the purpose of a drying agent? It is also to remove water. And here also, it also remove water. But what is the difference between them? In first case, when we use something as a drying agent, the substance does not change chemically. Not about sulfuric acid, the other substance. And when we are using as a dehydrating agent, the substance changed chemically. So example, if you have a container which is filled with concentrated sulfuric acid, H2SO4, it's a formula for sulfuric acid. We add a moist air. Moist air means the air contained water vapors. So when we bubble the moist air through a sulfuric acid, the air will escape. The air which will escape, that air will be dry air. So you can see there is no chemical reaction. The substance, the air, which is a mixture of nitrogen, oxygen, carbon dioxide, does not chemically change. It remain air, the mixture, but only the water is removed. So if water is removed without a chemical change in the substance, we call that as a drying agent. So here sulfuric acid is a drying agent. But what is the meaning of dehydrating agent? Dehydrating agent, example, you have glucose, C6H12O6. When I add sulfuric acid, H2SO4, so sulfuric acid remain there, but sulfuric acid separate inside the glucose, it contain carbon, hydrogen, oxygen. So this concentrated sulfuric acid separate carbon and water molecule from the compound. So when it separate the carbon and water molecule from the compound, what we call sulfuric acid here, we call sulfuric acid is used as a dehydrating agent. In a sulfuric acid, there is no change, but it removes the water from the substance, chemically decompose or break down the substance. We call that as a dehydrating agent. So what we will observe when this reaction occur, carbon is a black solid. So we'll observe a black solid and a vapors formed. So the difference between a drying agent and a dehydrating, a drying agent remove the water from the substance, but the substance does not chemically change. But dehydrating agent remove the water from the substance and it chemically also changes. So there's a chemical equation when you are using substance as a dehydrating agent, but as a drying agent, there is no chemical equation, it's just a physical change. Is it clear the difference between drying agent and dehydrating agent? So sulfuric acid can be used as